I made a glycolysis video yesterday, and now we are going to talk about what the glycolysis does with the two pyruvates that are made after. So this step, I'm only going to go over precursor right now, and then I'm going to film the fermentation ones after this, but so this is an aerobic. This is a part of one of the steps in aerobic cellular respiration. This is called the precursor step. It's also called pyruvate decarboxylation. You don't have to know that, but it's just the precursor step. And not a lot of places talk about this, so I'm gonna talk about it now. So this whole process is gonna happen twice because remember we made two pyruvates in glycolysis. So now we have our pyruvate, which is a 3-carbon compound, and our pyruvate is going to get broken, and this 1 carbon is going to get released in this process as a form of carbon dioxide or CO2, which our bodies breathe out. And this is a byproduct of cellular respiration. And then this happens in the intermembrane space. So when we talk about a mitochondria, right, we have this, right? So this would be the outer membrane. Then this is the inner membrane space where this happens. This is called the cristae. And then this is the matrix, right? So this happens in this inner membrane space. And what's happening is that we have NAD pluses that are found in there. And when this pyruvate gets broken down, it transfers the electrons to NAD plus, and it makes NADH. And this is called oxidation because remember oil rig? So oil, the O, oxidation, is losing electrons. So pyruvate is undergoing oxidation, where it's losing its electrons. It's losing its 1 carbon as carbon dioxide, and then its electrons, the electrons are combining with NAD plus, and then the hydrogen ions or the protons already found in the inner membrane space, and it's making NADH. And as it's converting, it's trapping energy in NADH. And so then after these reactions happen, what we're left with is a enzyme called acetyl coenzyme A, which is a 2-carbon molecule with the coenzyme. Just know it's acetyl coenzyme A. And then this acetyl coenzyme A is going to be sent into the Krebs cycle, which we'll talk about later. That's really all you have to know. And so our inputs in total would be just 2 pyruvate because this is happening twice, and 2 NAD plus, but NAD plus is already found. So if it were to she asked what are some of the inputs that are excluding things that are already found in the area, it would just be 2 pyruvate, and our outputs would be 2 carbon dioxide because it's happening twice, 2 NADH, and then 2 acetyl coenzyme A. Yeah, that's pretty much all you have to know. This is a hiking easy one. And this it only releases a little bit of energy in the NADH. Most of the energy from the glucose is still in acetyl coenzyme A, and that's gonna be sent through the Krebs cycle. Hey guys, so this is about fermentation. So I showed y'all the precursor step, right? Hold up. I showed you guys what the precursor step looked like, but precursor step only happens if oxygen is there. What if we don't have oxygen or oxygen level are really low, okay? Then we go through something called fermentation. Fermentation happens directly after glycolysis, and it takes the 2 pyruvates and it takes it into other pathways in order to make ATP for cells, and we'll go over that. So fermentation, the main function of fermentation is basically to regenerate NAD plus to make ATP for cells, right? And so we have 2 ways. We have lactic acid fermentation and alcoholic fermentation. So fermentation, it happens us humans have lactic acid fermentation, and I'll tell you when that happens. But like for like small prokaryotic like bacterial like things, a lot of times they only need like a few bits of ATP. So that's why they'll go through fermentation, especially like bacteria that lives in like places like that. Bacteria that if they were exposed to oxygen, it would be really harmful to them. They do this because this is anaerobic, sorry. The fermentation is also called anaerobic respiration. This whole process where glycolysis and then the fermentations, this is called anaerobic respiration because it does not need oxygen. We have two types, right? Our first type, which is lactic acid fermentation, we can see this happen in the cheese industry, the dairy industry, when like pickles are made, things like that. It is all lactic acid fermentation. Sauerkraut, kimchi, it's when it's fermenting, but it's creating lactic acid, right? And then, so this is how it goes. Basically, we have two pyruvates, right? We have two pyruvates. Hold up. We have two pyruvates, and it's 3 carbon compounds each, right? And so then these two pyruvates, this is in low or no presence of oxygen. What's going to happen is that there's going to be 2 NADH that's found. Oh, this all happens in the cytoplasm, by the way. Cytoplasm. This all happens in the cytoplasm. So the NADH found in the cytoplasm, and this was made from the, I'm sorry, my dad came. This was made from the glycolysis step right here. You can see NADH. It's sent to lactic acid fermentation, and it combines with a hydrogen ion, and it loses electrons, and it becomes NAD plus, right? And this NAD plus is then sent to the glycolysis step right here. Do we see how NAD plus goes from here, like here? And after these reactions happen, we are left with lactic acid. In us humans, we go through lactic acid when we do like running and stuff, because when you're running, you're not taking in as much oxygen that you need to keep cellular respiration happening, because you're you're exerting your oxygen, but you're not taking enough oxygen in. So your body will resort to lactic acid fermentation, and our cells like adapt, and that's like how we get it. And basically, after a human runner does lactic acid fermentation, after they're actually in something called oxygen debt, right? And oxygen debt is basically like when they are running, okay, like we have like a little guy, okay, and he's running, okay, right? And he's running a lot, right? And so in his like stomach, he has a lot of buildup of lactic acid, right? And the only way to get rid of this lactic acid is through breaking down the lactic acid using oxygen and break it into materials for the body to use, right? So like the only way that you can get rid of all this buildup of lactic acid is with more oxygen. And if he already doesn't have enough oxygen, that's why he was doing lactic acid in the first place. So that's why he's called an oxygen debt. And that's why it's so important after you're running to take like deep breaths in and out, or this can cause like muscle soreness. And that's why actually people have muscle soreness, or actually cramps, or like soreness just, and like cramps in general. I know me personally, I can relate this to myself because I'm really lactose intolerant. So this lactic acid that gets built up, it gives me really bad cramps after I run and stuff. But you know, so that's basically like how that's lactic acid, right? And then the other type, and this is found in the cheese, the sauerkraut, kimchi, pickles industry. Alcoholic fermentation is where the 2 pyruvates from glycolysis, right? Remember our 2 pyruvates. It is turned into 2-ethanol, which are if it says OL, it means an alcohol. And basically it's alcohol, right? And so these pyruvates, and let's just talk about like one in specific, okay? Like I'm only talking about one of the pyruvates. The pyruvate is going to get broken down the middle. And then this one carbon is going to get released as a carbon dioxide, just how I showed you in the precursor step, remember? It's going to happen again in alcoholic, and then it's going to leave off as 2-ethanol. And the NADH from glycolysis, remember, is going to be broken down into NAD+. And then this NAD+ is sent back to glycolysis, and it regenerates the whole cycle. And then we're left with 2-ethanol. And this is seen a lot in the wine or bread industry. And like the longer that alcohol fermentation happens, like the better it is. Like in like wine, they say like the longer that it sits, like the better it tastes and stuff. That's why like people drink like really like, oh, he aged like fine wine, stuff like that, right? And like for bread, for instance, when bread goes through this whole process, it releases carbon dioxide, and like as it rises, right? And so we have a piece of bread, and when it's releasing carbon dioxide, we can see it in the air pockets of the bread. And that's actually proof of like the bubbles that happen. That's how you know carbon dioxide happens. And that's why like bread people, they want like big bubbles. And that's why, because that's how you know that the fermentation actually happened like really good. This is like especially in like sourdough bread. And then it's left off as ethanol, which is like, yeah. And also for lactic acid fermentation in humans, especially like for like this little guy, his after the lactic acid builds up and stuff, like oxygen is needed, but the liver is going to break down this lactic acid. And here's like a little recap. I drew this and it's really helpful. It's in the textbook. But basically we have glucose, right? And it's made into pyruvate. This is glycolysis step, right? In this like yellow, right? Over here. So, and then this pyruvate is sent into two different types of fermentations, right? Then we have the alcoholic fermentation, which makes ethanol, and then the lactic acid fermentation makes the lactic acid, right? And so you can see here clearly how this NADH sent to here in the alcoholic fermentation, and then it was broken down into NAD+. And then this regenerates the whole cycle. And the reason it's like, how is the cell getting energy from if this is happening? Remember, in glycolysis, we are making ATP, right? Are we not making ATP during this whole process? Exactly. So when we are constantly regenerating the cycle from on this side and this side, it's going to keep producing ATP, which is what the cell needs, especially, and this is all in without the presence of oxygen, because if oxygen isn't there, then the Krebs cycle can't happen and the electron transport chain can't happen, which I'm going to make a whole video about that. Don't worry, guys, I got you. But that's basically fermentation. It's really easy, honestly. That's all you have to know. I'll talk about it. So let's talk about like someone running, okay? For example, if they're running for a long period of time, their body isn't going to do lactic acid fermentation. The only way they can regenerate supply of ATP is through cellular respiration, but cellular respiration releases more slowly than fermentation does. That's why during a long race or a course of a game, like your body, it takes a while for cellular respiration to happen. But in like short sprints or something, your body will go to lactic acid fermentation to quickly make that ATP, because in lactic acid fermentation, any fermentation, we're not making that much ATP. We're only making like 2 ATP per time, right? But for example, in the electron transport chain, remember, we make 38 ATP. That's why our cells do cellular respiration if we're doing long running period times. That's basically it.